Thank you so much for the introduction, Ale. My name is Aidan O'Neil. I'm a first-year PhD student, and today I'll be presenting some of my preliminary work from helper hindrance and analysis of combined heat power in the United States industrial sector. So to introduce, I'd like to bring up this pie chart because it shows a breakdown of greenhouse gas emissions across the various sectors in the United States. Unlike the transportation sector or the electricity sector, where we have known strategies to decarbonize, industry is often seen as a hard-to-abate sector, meaning it will be more challenging to decrease the emissions from this sector. And that's largely due to the large heat and energy demands from the industrial sector, high cost of abatement technologies, expensive capital investments with long-term feedbacks. And all of these are important for the industrial sector, but they're also important for combined heating power. So what is combined heat? Combined heating power is a system where instead of purchasing electricity from the grid and generating heat from a boiler on site, you do both at the exact same time. And this leads to energy efficiency savings as well as cost savings, which is why it's been used in the past. And as you can see, we normally thought that this has led to a decrease in greenhouse gas emissions. So conventional generation has more greenhouse gas emissions than combined heating power. But as the grid begins to decarbonize, this is becoming more and more of a question. So my research is focused on, will CHP in the industrial sector help or hinder US net zero emissions progress and clean air progress? So in order to do this, I downloaded the database of all CHP systems within the United States, and then created an engineering model which takes into consideration grid intensity data over time, fuel emission factors, and assumptions about efficiency and runtime in order to determine which CHP systems are emission savings and which are not. And I would like to now talk about it using my favorite product from the manufacturing sector, chocolate. So this is an example of the Ghirardelli chocolate CHP savings CHP system. And like you can see, in the past, there has been great emission savings. But as the grid continues to decarbonize, what we're seeing is this emission savings gap is decreasing. And slowly over time, if we include a business as usual scenario for grid decarbonization, we can see that these CHP systems will actually be emitting more greenhouse gases than conventional generation. In fact, when we look at the industrial sector as a whole, out of the 619 industrial CHP units, 90 are already in excess, and 362 will be in excess by 2050. Like I said, you can see that the gap in emissions savings across the whole fleet for CO2 is shrinking now that the grid is decarbonizing. However, if we look at NOx and SO2, we can see that this break-even point, or the point where CHP is actually hindering progress, is actually disappearing, or in fact, has gone away completely. As you can see, in 2015 and in 2018, the CHP is actually higher than conventional generation. So the next steps of this is to address some of the gaps in the literature, which is to include CHP within decarbonization scenario planning, as well as doing decarbonization scenario planning across a variety of sectors. I hope to do this in the state of California.
Questions for Aidan?
Hi, Aidan. Great talk. I was just curious, where are the plants that are already in excess of emissions with the combined heat and power?
Yeah.
Thank you.
So there is both a geographic component to that. So you might expect that in grids that are low carbon, like Vermont, you might have CHP systems that are already in excess. But another thing that's very important is to consider the fuel that these systems are using. So for example, if you have a coal-powered CHP facility, that is going to be more likely to be in excess due to the fact that coal has been vastly removed from our grid.
Hi, Aidan. I think I missed something. Can you explain why
we initially thought that CHP should be less carbon intensive, but then it becomes more carbon intensive. I think I'm just fundamentally misunderstanding that.
Because you're able to both at the exact same time. So power stations will likely generate a lot of, and normally that just lost. So in a CHP facility, you're able to then use the heat that is generated during electricity generation and then use it in your process as well. So it's kind of like killing two birds with one stone.
But wait, but then didn't you say that over time they then become more carbon intensive and less efficient? You said like that. Did I misunderstand the graph? Yeah.
Here?
Yeah, I guess, and I think there was other graphs that saying that like over time now the CHP actually is becoming.
Yeah, this is the app of the entire CHP.
Oh, it's not efficiency. It's just
Yeah.
okay.
And the reason why we see growth in that intermittent is because more CHP facilities are being built as we speak.
Is the blue here the equivalent energy or the equivalent CO2 emissions if we were electrifying it compared to the CHP?
Fine. So purchasing electricity from the grid and then also using boiler to create it.
Okay. Thank you.